Hi friends, today we are going to see about the sight distance in the geometric design. So first of all, what is the sight distance? The sight distance is one of the important factor in the geometric designing of a highway. The sight distance is nothing but how much distance is visible to the driver. In other terms, you can see how far the driver can see so that he can take an action. It may be an obstruction. So during this driving, he wants to stop the vehicle on seeing the obstruction, or it may be during the time of overtaking. So he has to see the oncoming vehicle, whichever the vehicle is coming in front of him, so that he can safely overtake. And during the intersection, during the uncontrolled intersection, where the driver can cross the road freely without getting any accidents or without having an obstruction to drive or cross freely the intersection. So there are three types of sight distance. One is the stopping sight distance. So that is SSD. Second one is the overtaking sight distance, that is OSD, and sight distance at intersection. Right? So what is the stopping sight distance? So when a vehicle is traveling, say at a speed B, when a vehicle is traveling at a speed B, so suddenly when the driver sees an obstruction ahead of him, so whether the sight or the visibility of the driver is sufficient enough to make a halt, so that he will avoid getting hit into the obstruction, right? So whether this distance is sufficient for the driver to stop his vehicle, this distance is known as the sight distance. For analyzing purpose, the height of the driver's eye is taken as 1.2 meters from the ground surface, and the height of the obstruction is taken as 0.15 meters from the ground surface, that is a half feet scale. So how far you can see a obstruction is equal to a half feet scale at a height of 1.2 meters from the ground level, right? So this distance is known as the sight distance. So here the stopping sight distance is nothing but, so when the vehicle is traveling at a speed V, so suddenly the driver may see some obstruction ahead of him. So what is the distance traveled by the driver in order to stop from the getting hit from the obstruction, right? So the stopping sight distance is calculated by lag distance and braking distance. So first, what is this lag distance? This lag distance is nothing but, so when the driver is driving a vehicle, suddenly he sees an obstruction, right? So what the driver will feel, suddenly he will have some reaction. So the reaction or the psychological happening in the driver is known as the reaction time. The time taken for the driver to react to the situation. The psychological effects is going inside his body. That is known as the reaction time. So during that time the vehicle may travel to some distance. That distance is known as the lag distance, right? So this lag distance will be varied from person to person depending upon their skill of driving, depending upon their age, etc. So usually a younger person or a person who is more experienced in driving will have a less reaction time, whereas some elder person or those who are having a poor skills in driving will have a more reaction time. So this lag distance will be varying from person to person, but as per standards they will be taking it to be somewhere around 1.5 seconds. So in several codes or several specifications around the world suggest from 1.2 to 1.5 seconds, right? So this is the time they have taken for the reaction time, the time taken for the body to analyze the situation and then to react. That is being in some PIEV theory, based on this PIEV theory. So what is this PIEV theory? Perception, intellection, emotion and violation. Perception is perceiving what is happening. Then intellection is the data is going through the spinal cord into the brain and coming back. Then emotion, the happenings occurs in the body. That is emotion. Then violation is the action that is taken. So these four theory, based on this PIEV theory, it has been proposed that average time, reaction time between taken for the driver to react is between 1.2 to 1.5 seconds. During that time, the vehicle may move to some distance. And after applying the brake, say after applying the brake, the vehicle will be moving to some other distance. So that is known as the braking distance, based on the efficiency of the brakes. The braking distance will be based upon the efficiency of the brake. The driver, once he presses the brake pedal, so what distance there is traveled, right? So here the lag distance is nothing but, you know that basic formula, speed equal to distance by time. So distance is equal to speed into time. So here the speed is the speed of the vehicle, that is small v. So here the small v represents in meters per second. This is taken as a universal acceptance that smaller alphabet denotes in SI units. Whereas if capital V may be in miles per hour or kilometers per hour based on the country to country variation. So here we will take capital V as kilometers per hour and small v as meters per second. Right? So meters per second is the speed. Then time. Time is the reaction time. Small t represents the reaction time. It may be from 1.2 to 1.5 seconds, right? Then next we have to go to the braking distance. What will be the braking distance? What will be the distance taken by the vehicle to entirely stop the vehicle? What will be the time taken for the driver to stop the vehicle? That distance traveled is known as the braking distance, right? So that can be calculated. So the vehicle is moving at a speed. So work done in stopping the vehicle will be equal to the kinetic energy of the vehicle. So you will be applying the brake, so the vehicle will try to stop. So the work done in stopping the vehicle. So work done is nothing but force into distance. So work done equal to force into the distance. You know that force can be split as a weight into coefficient of friction that we have seen in the engineering mechanics. Engineering mechanics, we have seen that any force and the body is moving along the force along with the friction, the force required to move the body will be equal to the coefficient of friction into the weight of the object, right? The coefficient of friction will be based on the various factors, that is based on the surface of the pavement or the tires pressure, all those things. That no need to go into that detail. So anyway, coefficient of friction into weight of the vehicle into L. This will be the work done. Similarly, the kinetic energy. Kinetic energy is half mv square from the law of motion. Kinetic energy equal to half mv square, where m is the mass of the vehicle in kilograms and v is the speed in meters per second. So if you want to write in terms of weight, so w by g into v square. So you know that weight is nothing but mass into acceleration due to gravity, right? So weight is nothing but mass into acceleration due to gravity. Acceleration due to gravity is 9.81 meters per second square. So W 1 by 2 W g into v square. So work done is equal to kinetic energy. So if you say keep it as 1, let this be 2. So 1 is equal to 2. So work done in stopping the vehicle will be equal to the kinetic energy. So it will be, if you equate it, half W v square by g. So if you equate it, W will cancel, and here L is nothing but the distance required to stop the vehicle. So L is nothing but, so here L equal to, so we can with the v square by 2gf. Right? This is the braking distance. So the formula becomes dt plus v square by 2gf. So this is the stopping side distance, the distance required for the vehicle to come to a halt on seeing the object. So this is the side distance or the stopping side distance, where the distance required from the vehicle to the obstruction to stop is vt plus v square by 2gf. So here, if you wanted to directly write it in kilometers per hour, so this is in meters per second. So meters to kilometers, if you want to convert, it will be 1000 divided by 60 into 60. That is nothing but 0.278 capital V into T plus 0.278 capital V square divided by 2g into f. Right? So you can keep it directly, you can substitute it in the kilometers per hour, or you can put it in meters per second, depends on your convenience. So this is the stopping distance. So total the vehicle, the distance required for the vehicle to stop on seeing the object to come to a completely halt is dt plus v square by 2gf. In case if it is not a plane having a smaller gradient, say for example a small slope is there, the slope is 1 in n. So the slope is there, then the coefficient of friction will vary, right? So suppose if it is an ascending gradient, the vehicle will be having a much easy to stop very much sooner than the flat gradient. If it is a descending gradient, the vehicle will be having a longer time to stop. So here the formula changes as, there's a gradient, so the formula will be changing it as dt plus v square divided by 2g. Instead of f, it will be f plus or minus 0.01 n, where n is represented in the percentage of 100, 1 in n, 1 in 30, 1 in 20, 1 in 60 and so on. So if there is a small gradient, this n will come into picture when the coefficient of friction value. If it is an ascending gradient, it will be f plus 0.01 n. If it is a descending gradient, it will be f minus 0.01 n. Right? Is it clear? So this is what the stopping side distance is. Next we will move on to the overtaking side distance. Overtaking side distance is nothing but how much the distance that can be seen while overtaking a slower vehicle. So, okay, so how much distance you can see for the oncoming vehicle. So what is the distance of the oncoming vehicle coming, so that whether it will be safe to overtake a particular vehicle. What will be the time or what will be the distance required for safely overtaking. In some places there may be a small roads will be there, right? So here it is almost impossible to overtake. Suppose if a huge vehicle may be traveling or something, or a truck or something, right, it will be very much difficult for a vehicle to overtake because there will be no space for oncoming vehicles will be there. So there will be has to be some portion on the road so that it will be having a safe distance to overtake. So this distance is known as the overtaking zone. So this zone is provided for the fast moving vehicles to overtake the slow moving vehicles. We have to find what is this distance so that the vehicle can overtake easily. Once the vehicle enters here, on seeing the vehicle coming in opposite direction, so here it has to have an opportunity to overtake. Mostly this kind of roads you can find it in hilly areas. In hilly areas the road considered very much small. In some places they have to provide some space for the vehicles to overtake easily. Also in some places of plains also. So this distance you have to calculate. What is the safe distance for the vehicle to overtake easily? Say for example, here one slow moving vehicle is going, say for example truck or something. A slow moving vehicle is going. So here a fast moving vehicle is coming, right? So say it is going at a speed of say some 30 kilometers per hour. This fast vehicle is coming at a speed of 80 kilometers per hour. So it wants to overtake the slow moving vehicle. There are oncoming vehicles also there. So when the vehicle wants to overtake the slow moving vehicle, what will be the first step? First step of this vehicle, say let this be A, vehicle A, let this be vehicle B, let this be vehicle C. So vehicle A's first step will be reducing in the speed. So this will decelerate and this speed will be equal to that of the slow moving vehicle. It will be keep on following, right? So from vehicle A it will be keep on following the vehicle B. So say for example vehicle A is coming from this direction. So this is A1, say this is A2. So from A1 to A2 the vehicle will be slowly moving. So B is somewhere B7 here. So B will be moving in the slow moving and the A also will be slowing in the speed, and from here A1 to A2 it will be moving at the same speed as that of B. So this distance, let this be D1. So d1 is the distance moved by the vehicle A from A1 to A2 at a speed equal to that of the slow moving vehicle B. At this point A2 he sees the oncoming vehicle C. So from this point he wants to overtake the vehicle B. So what he will do at this point, he will accelerate. He will accelerate from this point and he will cross to the other lane and he will overtake and he will come. In the meantime, this vehicle B will be somewhere moving around here. Right? So he will overtake and he will come to this position. So A1, A2 and A3. This is B1 and let's say this point to be B2. The vehicle B moves from B1 to B2 at the same 30 km per hour. So at this point he will start accelerating and come to this point. By the time he is accelerating and coming, the vehicle C from point C1 will move to point C2. Right? So A2 to A3. Then we will keep this as D2. So D2 is the distance taken by the vehicle A in crossing to one lane to other lane and then again regaining back to the original lane. And this distance we will keep it as D3. So the entire overtaking distance from A to A1 to A3, this total distance is known as the overtaking side distance, right? So here the spacing between the A2 and B1, let this be S, and the distance or the distance travelled by the vehicle B, let this be B, small b, and from here to here again the spacing will be there, that will be spacing S. Spacing is nothing but we can see that there should be some space should be there between the vehicle which is moving in front to the vehicle which is following it, so that to have a safe movement. So this spacing may be denoted as, you can take some value to be BB plus 6. So 70% of the speed of the slow moving vehicle plus 6 meters. So this is approximate empirical formula. Empirical formula they have right. It can be 0.2 VB plus 6 or 0.8 VB plus 6 and so on. There will be a lot of empirical formulas. But the standard empirical formula that will be practiced is 0.7 VB plus 6. 70% of the speed of the slow moving vehicle plus 6 meters interval. And then this B is nothing but the distance travelled from B2 to B3. And again the spacing will be coming to the A3. So the total overtaking distance is D1 plus D2 plus D3. Right? So here D1 is nothing but the speed of the vehicle B into the reaction time T. So that will be reaction time taken by the driver. So he will be slowly moving and then he will accelerate. So the slow moving time and the reaction time to be taken as T. And here this D2 will be equal to B plus 2S. Is it correct? B plus 2S. And D3 is nothing but speed of the vehicle C into the time. D3 is the time taken by the vehicle from C1 to C2, that is during the entire overtaking time. So here we will keep it as capital T as overtaking time. So small t is as reaction time. So VC is nothing but the design speed of the road. Right? We can also get a small v itself. That's not an issue. So VC into T. So D2 is B plus 2S. You know that according to the law of motion, distance equal to ut plus half at square. This is the law of motion, right? So if you equate this distance with this B plus 2S, u is nothing but initial speed, that is speed of the vehicle B, and t is nothing but the during the overtaking time plus half of acceleration into t square. So here capital T denotes the time from A2 to A3, that is the overtaking time, that is C1 to C2, A2 to A3, that is the capital T. So if you equate it, but B we know that BB into T, isn't it so? So 2S is nothing but AT square by 2. 2S is nothing but AT square by 2. So if you want to know the value of T, then you can calculate 4 into S divided by A, the whole root. So this is the value of overtaking time if you wanted to calculate. So d2 is nothing but VBT plus half a t square. So here if you want to calculate t, this is the formula. If you know that, yes, S is nothing but the spacing. Spacing you can find it from this formula. From this formula you can find the spacing. Then acceleration, you know that. So spacing and acceleration substitute, you can get the value of capital T. In this capital T, if you substitute in this equation, we can get the value of d2. So total overtaking side distance is nothing but d1 plus d2 plus d3. So overtaking side distance is nothing but d1 plus d2 plus d3. So that is VBT plus ut plus half a t square, or you can say it's b plus 2s. So here b plus 2s. So you can also write b plus, b is the distance, we know that. Then instead of 2s you can write as a t square by 2. So this is d2. For simple calculation, our aim is to find the overtaking side distance. So d1 VBT plus b plus a t square by 2. If you want to find t, you can use this formula, substitute here, then you can get the value of t, that you can substitute it here. Then d3 equal to Vc into t. This Vc, if you know, that no problem. If you do not know, you can take it as the design speed of the particular highway or particular road, right? So this is the overtaking side distance. So in case if you want to implement this, usually we have to provide some direction. Say for example, road is like this, and then the overtaking zone is provided, and then the overtaking zone ends. So here you have to provide a symbol saying overtaking zone ahead, overtaking zone ahead. Similarly, here overtaking zone ends, overtaking zone ends. Here overtaking zone begins. Similarly from this side, here overtaking zone begins and overtaking zone ends. So what is the distance that you have to keep is, usually the same permissible value given is 5 times the overtaking side distance. Minimum 3 to 5 times the overtaking side distance you have to keep as the board, sign board. So the driver will be ready to overtake. So this overtaking zone begins, will be kept at a distance of 3 to 5 times the overtaking side distance which we have found out from here. This you have to keep it. Similarly, before the end of the overtaking zone, you have to provide this. This is also the distance of 3 to 5 times the overtaking side distance. So here you have to keep a board that the overtaking zone ends. So that after this the driver will be having a, even if they want to overtake, this is the last minute chance. After that they should not overtake. So here the display should be there. Similarly to the oncoming side also, right? The last one is side distance at intersection. So in many developing countries, this side distance at intersection becomes questionable at the uncontrolled intersections. So there may be some development occurring at the end portions. There may be shops, or there may be obstructions, there may be buildings, etc. So vehicle coming from this direction, he cannot view what is coming from this direction. So he has to see, suppose a vehicle is coming here, we have to see whether he can speed up or he can slow down, or what the decision that has to be taken by the driver is at stake. So there is some conditions which the intersection should satisfy. Condition number 1 is the vehicle should able to speed up, or the vehicle should able to slow down or coming in intersection. He should be knowing what speed he has to take. Then the last condition is the vehicle should safely cross the intersection. So this is the intersection at side distance. So what is the side distance that has to be provided? So suppose if there is a construction here or building here, this should not be left it like this. It should be avoided. Here the construction should be avoided such that the side distance should be visible for the driver when the vehicle approaches the intersection. The vehicle should see what is coming in the other side. In other words, in simple terms, the vehicle coming in one side of the intersection should be able to see all the legs of the other intersections. So it should not be any obstruction or any barrier so that the vision is obstructed. So he has to see all the legs of the